All right, students, it's Mr. Rich. Welcome. It is another Mr. Rich Q&A on Sunday night. It is Sunday, the 26th of January. I've got some questions that have been submitted. We're going to take a look at those first. Anybody that's here, if you do have questions, you can submit them to me at askmrrich@gmail.com, or you can post them in chat. Best thing to do is if it's on paper, take a picture of it. If it's on Delta Math, take a picture of it and just email it to me, and then I'll slap it up here on our whiteboard and try to give you some help. The first question I have comes from Algebra 2, and it deals with simplifying radicals. I'm going to share my screen and let's jump right to it. And there we go. So I will zoom in on this and take a look. So this looks like, I don't know if you can read that, but I believe that that looks like a -5. And I'm going to say that that's a fourth root. That looks like the fourth root of 128. Okay, great. Thank you, Amber. Appreciate it. Help me out here, Amber. You can reply here in chat. Is that -5 and the fourth root of 128? Because it looks like there's a 4 in that index. Yeah, okay. So then what we're going to do to simplify the radical, anytime that you're dealing with roots of radicals, right, or a radical that has a root, and they all have roots, but you want to consider what are the perfect powers for that root. In other words, if this is a fourth root, I'm going to make a list of all of the perfect 4 powers. In other words, 2 perfect 4 roots, which would be 2 to the 4th, which is 16, 3 to the 4th, which is 81, and 4 to the 4th, which is 256. So to simplify this, I am definitely looking to see if this 128 is evenly divisible by one of those perfect 4 roots. I'm going to use my calculator here and assume that 128 would be divisible by the number 16, and it is. It's divisible by 16, and it gives me 16 times 8. So I would rewrite it like this. It's -5 times the fourth root of 16 times 8. Well, 16, the fourth root of 16 is 2, right? Because I know that 2 to the 4th is 16. So the 16 comes out as a 2 and gets multiplied by that -5, leaving behind the fourth root of 8. And that's as far as we can go right there. If you see me do something that you're like, this guy doesn't know what he's doing, or that doesn't make sense, or boy, he just made a big mistake, let me know, please. I do make mistakes. Ask my students. It's possible for everybody to make mistakes. I try not to, but that's what we do. That looks like just the square root of 150. Would that be right, Amber? Square root of 150? I think just based on what your work is here. So what we have to do if I'm taking the square root of 150, I do want to factor 150, but I want to factor it so that one of the factors is a perfect square. What are the perfect squares, right? They start with 4, 2 squared is 4, 3 squared is 9, 4 squared, 16, and then 25, and then 36. I'm just making myself a list here of all the perfect squares. And I'm looking for the largest one that would divide into 150. And I believe the largest one is going to be 25. So I'm going to take 150 divided by 25, and it is 6. So my factoring that I want to use here is going to be to express 150 as 25 times 6. Okay, like that. So then what I can do is I can then pull out the square root of 25 as its square root 5, and then that becomes my answer, 5 times the square root of 6, like that. Oh, and there's an r? Oh, okay. Well, you know what? That r is not going anywhere. The r has to stay put with the 6. So it's going to end up being 5 times the square root of 6 times r. Now, why does the r stay put? Well, let's see if we can see another problem with radicals that has a variable in it. I'm going to take a look at, stop this share real quick and go to the next sheet. I think that's the next sheet. So let me grab it. Okay, and then I'll drop it over here. Okay, and that's the same one. Bear with me, students. Almost got it. And again, if you just joined, if you have some questions you want me to answer, please email them to me, askmrrich at askmrrich@gmail.com, and I'll share my screen back. There it is. All right, what I'm going to do, I'm going to drop down here and do one of these down here, simplifying radicals. I know that's a little fuzzy. I'll rewrite it so that everybody can see it. So this is going to be a 2 times the square root of 10x squared minus 3 times 6x squared. I believe that's what that is. Can you confirm that, Amber? I think that's right. But anyways, what I'm going to do is if this is subtraction, kind of looks like it could be multiplication. Is that a multiplication in there, in between there, Amber? It is. Okay. So we're actually multiplying these guys together. So here we go. So I am multiplying this and this. So when I'm doing this multiplication, I am going to multiply the two parts that are on the outside. That would give me, if I'm multiplying radicals that have the same index or the same root, I can do the multiplication and put it under one radical. So 10x squared times 6x squared, I could write that as 60x to the fourth. All right. And then I am looking to see if there is a way for me to simplify this. So I want to see if there's a way to simplify 60. Since this is a second root, right, we're considering all of our perfect squares, 4, 9, 16, 25. And I'm wondering if one of those divides into 60. The only one that it could be perhaps is 4, so I'll divide it by 4. It is. So what I'm going to do is I'm going to rewrite this as 15 times 4 times x to the fourth. And remember, Amber, so what you want to do is make sure when you're factoring the 60, make sure that you're using a factor that is a perfect square. I don't want to say that this is 30 times 2 because neither 30 nor 2 are perfect squares. But the square root of 4 is 2, so I can bring that out and multiply the square root of 4, which is 2, times that -6 to give me a -12. Well, that leaves me with times x to the fourth. And now what I can do is take the square root of x to the fourth. How do I do the square root of x to the fourth? Well, what I'm going to do is I am going to divide this index into the exponent. This is the easiest way to radicals where the variable has an exponent. How many times does 2 divide into 4? It goes in twice. So that means I get to pull an x squared out. And when I divide 2 into 4, there's no remainder, therefore there's no x's left. And so my final answer becomes -12x squared times the square root of 15. Any questions on that? Okay, very good. I will show you one more thing. What if it was x to the fifth? Let's just change it up. Suppose that we did all this work. It ended up right there. I would divide the 2 into 5. It goes in twice. 2 goes into 5 twice, so I still pull an x squared out. But when I divide 2 into 5, the remainder is 1. So therefore, there remains a 15x to the 1 power right there. All right, I got some other ones that I don't remember what class this one is. So let me go grab those and I'll pop them up here and we shall see. These, you know what? This might be this might be SAT. I think this is one of my SAT students. Man, you're really putting me through the grinder here with this one. This one looks like a tough one. Let's see. Drop that there and then let's see. Might as well get the other ones while we're at it. Right? So everybody can benefit. Oh my gosh, I can't believe I've worked this problem earlier today with a student. That is a hard problem. Okay. I was reviewing a student's practice test and this one came up. All right, I'll share the screen. Take a look. And these are the SAT questions. I'm going to take a look and see if any other questions came through. That's all I show. So these SATs are the last ones. And I don't think it's going to take me the rest of I know it's not going to take me the rest of this time. So I need more questions. If you have any, send them in. Again, askmrrich@gmail.com. All right, so this question here says, if ax plus 2 times bx plus 7 is 15x squared plus cx plus 14 for all values of x, and if a plus b is, what are two possible values for c? That probably sounds confusing to most of you at first read. It's like, how in the world am I supposed to even start that equation, that question? Well, the approach that you want to take on these difficult SAT or ACT questions, sometimes you don't see the pathway to the solution. I doubt very many people read that and go, oh yeah, I'm going to do this, 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 and this, and then I'll have my answer. It doesn't work that way. What you have to do is start the ball rolling and do something that you know that you normally would do for an equation. For example, I think what I'm just going to do is I'm going to expand that product of two binomials. I'm going to multiply them together and then see what I have and reassess. If I FOIL this, right, if I distribute the AX and the 2 through the BX plus 7, that's going to give me A times BX squared plus 7AX plus 2BX plus 14. And that's supposed to be equal to 5X squared plus CX plus 14. Then I step back and take a look at this. Well, what I'm doing here is I'm going to do something that we call matching coefficients. Because if these two expressions on either side are equal, and they are, then what has to happen is the coefficient in front of the x squared term, and there's only one of them over here, has to be equal to the coefficient of the x squared on the other side. So I'm going to write that result down, that A times B has to be 5. Now, and I'm trying to find a value for C, right? So what else though do I know? Well, the 14s match. So I could subtract 14 from both sides. So that's inconsequential. They're kind of gone. But then what I have, these both are x terms. So if I took that equation and factored out the x as a common factor, what you get is 7a plus 2b times x. And that's equal to 5x squared plus c times x. So using this idea of matching coefficients, that coefficient in front of the x has got to be equal to that coefficient, right? And again, I can honestly say this is the first time I've seen this problem. So I don't know the pathway exactly. I've seen similar problems to this, of this kind, but I don't know what's really going to happen here. I'm just going with the flow here and doing some algebra. So what has to be true is that C has to be, that coefficient has to be equal to 7a plus 2b. And they also told me that a plus b has to equal 8. But that's interesting. So a plus b is 8, but a times b is 5. So what am I going to do? Let me see. If you've got some ideas, Joe says he thinks it's 15. Oh, not 5. Where? Oh my gosh, Joe, thank you. 15. Joe saved the day. I would have been out in the dark if you didn't tell me that. Thank you. So a times b is 15. So wouldn't that stand to reason that it looks like a and b are 5 and 3? 5 times 3 is 15. 5 plus 3 is 8. Now, which one is it? Well, I guess we don't know, but that's why there's two answers over here. So C could either be 7 times 5 plus 2 times 3, or maybe C is 7 times 3 plus 2 times 5. 35 and 6 is 41. 21 and 10 is 31. So Joe, I'm going with D. That's my final answer. Joe is my phoned in a friend right there. I sure appreciate it. Okay, so you may look at that and go, there's no way I could ever get that problem right. How was I supposed to know to do all of those steps? Well, you're not supposed to know those steps, because that's why these people that write these questions get paid the big bucks. A guy probably spent, or a lady, whoever, spent probably a week on that problem, okay, coming up with this problem. I'm exaggerating, but it takes a long time to come up with a problem that's unique, that no one has ever seen before. So the way that you get better at these is just by practice. You do more and more difficult problems, get coaching from somebody who could maybe lead you and help you get to the next step on a problem, and you just keep practicing. Okay, good one, Joe. Not only did he provide the problem, but he gave the assist and found my error there. Next, 26. I already don't like this one. This says, let x and y be numbers such that negative y is less than x is less than y. Which of the following has to be true? They put no constraints on what X and Y could be. It's just that they're numbers. So I think what I'm going to do is just come up with a scenario. I'm going to come up with that would be true. Is there another scenario that would be kind of weird? Yeah. How about this? What if it was -5 less than -3, 5? Right. Those would all fit the bill here because they didn't tell me X and Y had to be positive. And since I see an absolute value hanging around out here, stands to reason I probably want X to be both positive and negative to test these cases. So does X have to be, let's go to this one. Does X have to be, must be true? Not could be true, must be true. No, I already showed you. X doesn't have to be greater than 0. Does Y have to be greater than 0? Maybe. Wow, that's a good question. Yeah, it has to be. Because how in the world, what if Y was 0? No, no. Yeah, there's no way that Y could be 0 or negative, because then I would have that. And that's that positive will never be less than that negative. So must be true. I think that is true. Now, here's the absolute value. In this case, the absolute value of 3 is less than 5. And here, if X happens to be negative, it would still be the absolute value of the -3 is less than 5. So I believe it's 1 and 3, Joe. That's what I'm going to go with there. Okay. And then, oh man, this is the doozy right here. I'm looking for, okay, so what I'm going to do here, Joe, I'm going to put that one off. I'm going to go and take a look at a few other questions, and I'll come back to that one. Okay, what we've got here, yeah, this looks like pre-calc. So I'm going to grab this one, and then we'll come back to that one. Joe's probably saying this guy doesn't want to do that problem, and he's putting it off, and that might be half true. I don't know. All right, I got to get this out of the way, and let's copy this and bring this over. So here's the next question. Determine the period from a trig equation. This has got to be AP Precalc. Okay, what you need to know about functions of sine and cosine is that their period is always going to be 2 pi divided by the coefficient that's in front of the x. In this case, that's what we call the b. I think in the AP they maybe use little b, that coefficient in front of the x. But so 2 pi over 3 pi, that's basically our answer for the period. The pi's cancel, and so the period is just 2/3. All right, so that would be 2/3 of a radian, basically. But the answer is 2/3. All right, I got another one. Oh, all right, let's do this one. I like this. So this is writing an equation from the graph of a trigonometric function. Also going to be pre-calc right here. So when we write equations of sine and cosine, so the first thing that you want to recognize here is that this is a sine function, because sine functions start at their midline and then go to a max and then to a mid. Cosine starts at their maximum and then go down from there. So this is definitely a sine. Now, what we do is we use a standard form for a sine function, and this is what it looks like. It's going to look like this. And what is, I'm going to go ahead and just take a few minutes and explain what those coefficients A, B, C, and D represent. Well, this number that's right here, that would be it would be what we would call a vertical stretch, right? When we learned about graphing by transformation, when you multiply a function by a constant, it's going to be what we call vertical dilation. It's either going to be a vertical stretch or we're going to do a vertical compression if it's less than 1. So what we say is the absolute value of that coefficient is what we call the amplitude. All right, so amplitude is always a positive number. This could be a negative in front of the sign, and that would cause it then to flip across the x-axis, but that's what the A is. Now, the B has to do with what we would call a horizontal dilation, right? When you take any function and you put a multiplier in front of the x, you are doing a horizontal dilation. Now, the AP Precalc students are more familiar with these ideas of horizontal dilation. I'm going to give you an example of another type of function, right? If I gave you the square root of 3x. And there's another function, which is just the square root of x, which is the parent function. This function that has the 3 multiplier, that is going to be a horizontal dilation by a factor of 1/3, meaning that what we took is we took that function and we compressed it so that it came 1/3 closer to the y-axis. That's why when this number b in this sign is larger than 1, then what it's going to do is it's going to end up compressing the function and making the period shorter. Remember on that previous problem, I showed you the formula for period is 2 pi over b, because whatever that number is, assuming it's larger than 1, then it's going to shorten the period, which is consistent with what we learned earlier in the AP Precalc class, that when you stick a coefficient in front of the x, you take its parent function, and every point that was on the function becomes 1/3 the distance from the y-axis. It's a horizontal compression. But at any rate, when you look at this, well, I'll come back to that because I still haven't done the question, which is write the equation. The C right here is going to have to do with a horizontal shift. Just like any other function where we're doing transformations, if you pull the x out and replace it with x plus or minus a constant, you're going to cause the function to shift left or right. And then the plus d, as you well know, is a vertical shift. It's going to cause the whole function to go up or down. Now, this function right here that we're looking at, its midline, that is the halfway between the max and min, comes right across on the x-axis. So it has no vertical shift. So the d is a 0. The amplitude, which is the distance from the midline up to the maximum, is a 3. So that value a is going to be a 3. So we can start to write our equation. It's going to be 3. It is a sign because it starts at the midline. Now, what I'm going to do to figure out what b is I'm going to take that formula where I said period is 2 pi over b and solve it for b. Because if I'm trying to find the coefficient, I want to find the period off of the graph and plug it into 2 pi over period. Well, if I look at the distance from this midline crossing, skip the next one and go to the next midline crossing, that is the period right there. Or you could go from max to max right here. The distance between 5 pi over 2 and pi over 2 is 2 pi. So the period is 2 pi. So there is no horizontal dilation here because the period is 2 pi. So the coefficient is 1. There also is no horizontal shift because the sign is starting right at the 0, 0. So this is just, I say all of that to say that the answer to this is 3 times sine of x, like that. I know there's a long way to get there, but I kind of wanted to review what all of those coefficients are. And those of you that are in pre-calc, you're probably not at the point in your class where you're doing the complete equation for that. You're maybe doing part of it at this point. All right, Reagan, I hope that was helpful and maybe somewhat interesting. Going back to my inbox. Oh, Joe, unfortunately, I have to go back to your problem. No, I'm just kidding. So I'm going to grab it and bring it down here. So after I get done with this problem, I've got no more problems to work unless somebody submits something. Let's see what's in the chat. Oh, great, Reagan. Glad that helped. Let's take a look. The table gives the coordinates of 2 points on a line in the xy plane. The y-intercept of the line is k minus 5, comma b, where k and b are constants. What's the value of b? Again, this is an SAT question that's upper echelon. Right? This is one that I'm just guessing here, but I would say that probably less than 10% of students are going to get this one right. And that's fine. If you read this and you really don't have a way to start it, then you don't want to spend time on it. You probably want to go to the next problem, okay? But I'll show you a way that you could think through this. I got to take a sip. Joe, what's the score of that game? I would have it on my TV, but I cut the cable. Not like literally cut it, but we like Fired Comcast, and we're gonna get Sling or YouTube TV. 2116 Chiefs. Okay, well, they're coming back then. Well, this gives me coordinates of 2 points in a plane, and they're talking about a line, right? So the one thing that makes this maybe a little bit easier than other problems is it's a linear function. So what I'm going to do is I'm going to start with either the slope-intercept form of an equation, or I'm going to use point slope, because that's how we build equations of lines, especially those of you that are taking calc. If there's anybody in calc here, you know that we use point slope all the time when we want to make equations of tangent lines or normal lines, something like that. So what I'm going to do then is I'm going to take this and I'm going to calculate the slope of that line, because they're giving me the x and y coordinates. And you may say, well, I can't do that. They didn't tell me it's a k. That doesn't matter. I'm still going to use the formula for slope. Slope of a line, as you know, is y2 minus y1 over x2 minus x1. Well, I'm going to take negative 15 minus 13. That's my y2 minus y1. y2, k plus 7 minus k. The top is negative 28. Well, looky here. The k's cancel in this calculation. K plus 7 minus k is 7. So it turns out I do know the slope, and the slope is negative 4. What I'm going to do next is say, well, I am going to plug my slope into my point slope form. Y minus y1 is equal to negative 4 times x minus x1. The next thing that we normally do when we're coming up with an equation of a line, and why am I coming up with the equation of the line? Because I want to find out what the y-intercept is, right? Because I want to know what b is. B is whatever this is. B is the y-intercept. Well, what I'm going to do is I'm going to plug in one of the points that I'm given into the point slope equation. That's how we always do it. We say, give me 2 points, I'll calculate the slope, stick it in for, and then I'll take one of the points that you gave me and I'll throw it into the point slope formula. So if I take the k and the 13, I could take either one, but that I think is the easier one to use. It would become y minus 13 equals negative 4 times x minus k. All right, I want you to take a look at this and say, you know what? I think I know what k is. They told me that the y-intercept of the line is k minus 5 comma b. Well, isn't the x value for a y-intercept 0? Has to be. K has to be 5, because if you tell me the y-intercept is something comma b, that has to be 0. So k is 5. So I actually know the entire equation for the line, as it turns out. Y minus 13 is equal to negative 4 times x minus 5. Let me make sure I had that right, right? Yep, k has to be 5 to make x equal 0 in that ordered pair. And then to find b, b would be the y-intercept once I get this equation into slope-intercept form. So I have y minus 13 is equal to negative 4x plus 20. Add the 13 over, and I get negative 4x plus 33. That has to be the value of b, because b is the coordinate, the y coordinate of the y-intercept. It's the y-intercept. So 33 is my answer. And I can tell you that's not the only way to do this problem. There are several other ways without using the point slope form of an equation, but that is one way. Any questions or comments? Put them over there into the chat. And I got some more problems. Amber sent a few more over, so that sounds good. I'll do those. Give me a sec here. All right, Amber, did you just send one page over? It looks like one page came through. And then I'll plop this thing up here. Almost got it. All right, Joe, if that score changes, let me know. Okay, this got to share my screen. Yep. Okay. All right, let's do. All right, okay, this looks like a good one here. Taking a look at number 10. That looks interesting. All right, Amber, is that a third root right there? Oh, it is a 5. Okay. Yeah, it kind of looked like a 5. Is that a 5 then also? Or is that a 3? Oh, 545. Thank you. Got it. So what I'm going to do, right, if I'm going to simplify a fifth root, I got to write down the perfect fifth roots. So 2 to the fifth is 32. 3 to the fifth, I'm going to do it on my calculator. 3 to the fifth is 243. It's 243. I don't need to go any higher than that, right? That's that's 2 to the fifth and 3 to the fifth. Well, definitely 288 is not divisible by 243, but I'm wondering, is 288 divisible by 32? I guess it could be. It is. So what I'm going to do here is I'm going to write this first root as -5 times the fifth root of 32 times 9. And what I'm going to do is I'm going to, since the fifth root of 32 is 2, because up here, right, 2 to the fifth is 32. So that means that what I'm doing is I'm pulling the 32 out as its fifth root of 2. That becomes -10 times the fifth root of the number 9. Then we move over here. Let's go over to this fifth root. There's no way that I can simplify the fifth root of 9. So I'm going to just put that term next to this one, plus 5 fifth root of 9. Now I'm going to turn my attention to this fourth root right here. So now I'm going to write down my perfect fourth roots, right? 2 to the fourth is 16. 3 to the fourth is 81. So that means that if I'm going to simplify that fourth root of 32, I'm going to rewrite it as the fourth root of 16 times 2. I pull the 16 out as its fourth root, 2, leaving behind the 2. So I'll tack that on, right? This is a minus right here. So that means the next part of this answer is going to be -2 times the fourth root of 2. Now, one tip here, Amber, and anybody who's doing these radicals, is make sure that when you write your answers for your teacher, that you can't mistake your index for an exponent on the number that's in front of it. Okay, this is a +5, and this is a fifth root. So I'm tucking that 5 in there so it can't be mistaken as 5 to the fifth power. So this is -2 times the fourth root of 2. And then there's nothing to do that. Well, that's just a square root. It's a root 2, right? So it's a -3 square root of 2. Well, what I've got is I do have two like terms here that can be combined, because if I've got a fifth root of 9 and a fifth root of 9, those can be combined as like terms. So -10 and 5 is -5. So it's -5 multiplied by the fifth root of 9. And then there's nothing really to do in terms of combining those terms, because they're different roots and they're just added and subtracted. So all I can do is rewrite those terms in my final answer, and we get that. So that, Amber, there, I'm going to say is your final answer on that problem. So you're simplifying the roots and then looking for looking for like terms that could be combined together. All right, let's check the work here on 11. Okay, I like you're multiplying here. So you took the -4 times 4. Good. These are both fourth roots. Yep. And since that's multiplication, you can multiply these two together. But make sure that you do this, though. You did take, I assume, 108 times 15. Let's go over to Desmos here. 108 times 15 is 1620. But remember this, to the fourth times n to the first is to the fifth. So you want to change this to the fifth. Okay, now let's take a look at this. I'm going to change that color. This doesn't seem to be showing up. Yeah, maybe that's better. That kind of hurts my eyes. -16, fourth root. We've got 1620, and we have the fifth power. Well, since it's a fourth root, I'm going to, again, list out my perfect fourth roots. 2 to the fourth, 3 to the fourth, 4 to the fourth. And I'm looking for the largest number that of those perfect fourth roots that would divide into the 1620. I'm going to use my calculator over here. I'm going to take 1620 and see if it's divisible by 256. It's not evenly divisible. I kind of doubt it's divisible by, it is divisible by 81. Well, interesting. I think I need to go to a higher root here. That's 2 to the fourth, 3 to the fourth. Let's go 5 to the fourth power. Let's do 5 to the fourth is 625. What's 6 to the fourth? 1296. No, that's not going to work. Anyways, but we got 1620 divided by 81 is 20. No, that worked. Okay, I got it. So what we're doing here now, Amber, is we're saying we've got negative 16, and we just factored the 1620, dividing it by one of the perfect fourth roots, 81. We got 81 times 20, and then to the fifth. Well, the 81 is going to come out as its perfect fourth root. The fourth root of 81, because I said over here, 3 to the fourth is 81. 81 comes out as a 3, and it gets multiplied by that negative 16, making it negative 48. Also, Amber, this exponent on the is larger than the 4. So the 4 divides into the 5 one time. That means I get to pull into the 1 outside. What's left underneath the fourth root? Well, the 20 is left behind. And when I divided the 4 into 5 and got a 1, the remainder when I divide 4 into 5 is the number 1. So there still remains under here to the 1 right there. And then you got this, the 1 that is out here. So that should be your final answer. And our check to make sure that we simplified it all the way is to make sure that there's no more perfect fourth roots that would divide into the 20. None of these, 16 doesn't divide into 20 evenly. So there's no way to simplify 20. The other check is this is a power of 1, which is smaller than the index of the radical. So it can't be simplified anymore. That, unless I made a mistake somewhere, Amber, I'm going with that as my final answer. All right. Any other questions, students? I don't want to have to end this early. Wait a minute. Did something come through? Okay. What do I want to do? Still got some participants. Let me see who is here. Okay. I'm going to do a few pre-calc problems. What I was told by a few students today is it looks like the Unit 3 test that they're giving in some of the schools, I don't even remember which high school it was, but they're including some material from like 3, 8, 9, 10, and 11 into that Unit 3 test. And I believe what it's going to be covering are solving trig equations is the best I could tell. So I'm going to pull up a few problems on that. So give me a quick sec here and I will pull some up over. Yeah, I got a few. All right, so this comes from 3.10, and this is AP Pre-Calc. And here is an equation. It says, what are all the values of theta between 0 and 2 pi, where 4 times sine squared theta equals 2 sine theta? Well, what I need to do to solve this equation is do what I normally do with nonlinear equations, where I have powers on my variables, is I get everything on one side, try to get 0 on the one side, and then factor it, and then use the zero product property, which says that if two things are multiplied, or two or more things are multiplied, and the answer is 0, one of them has to be 0, and you split them into two separate equations. So I'm going to change this color back to blue. I'm going to take the right-hand side and subtract it over to the right side. And then I'm going to factor. And what I recognize here is I do have a greatest common factor that I can pull out, and that's 2 times sine theta. When I pull a 2 sine theta out, what's left is 2 sine theta minus 1 equals 0, like that. Well, this is where the zero product property comes in, that I got two things. I got that thing times this thing, which means the only way that equation could possibly be true is if one of those two things that are being multiplied is itself 0. So that allows me to say the solutions are found by setting the first thing equal to 0 and setting the second factor equal to 0. This is no different. We're using the same idea that you did when you factor quadratics, and you factor and you get that, you set the x plus 3 equal to 0, and you set the x minus 6 equal to 0. It just turns out you can do those solutions, -3 and 6, in half a second. this takes a little bit of time now to solve these equations. Well, and a knowledge of the unit circle. So I'm going to divide by 2 and I get sine theta equals 0. Okay, and then I'm asking myself, well, where on my unit circle is sine 0? Well, sine is going to be 0 when the y-coordinate is 0. The y-coordinates are 0 at 0 and pi and 2 pi, right? They wanted me to include 2 pi here, so I'm doing 0, pi, and 2 pi. Those are locations on the y-axis, excuse me, on the unit circle where the y-coordinate is 0. Solving this one, I get add 1 and divide by 2. I get sine theta is equal to 1/2. Then I consider where in the world on the unit circle are for what angle on my unit circle is the sine of that angle equal to 1/2? Well, first thing I do is think, what quadrants would that be in, right? Well, the sine is the y coordinates and y is positive in the first and second quadrants. So I would either visualize or I would sketch my unit circle in the first and second quadrants, and then find out where's the y coordinate equal to 1/2. And remember our pattern for the points along the unit circle, they go down like this: 1, 2, 3 on the x's and 1, 2, 3 back on the y's. I'm looking for y coordinates of 1/2. That's going to be at this angle and over at this angle. That angle, as you know, is pi over 6. This one is 5 pi over 6. So it turns out I got 5 answers to this equation: 0, pi, and 2 pi, 5 pi over 6, and pi over 6. So I'm going with answer B right there. All right, so I have a feeling that that is what you guys are covering. All right, I'm going to show you one more, and we'll go over just a little bit here, but I want to show you this one. This is wanting me to solve the equation when, for what values between 0 and 2 pi is that function equal to 0, f of x equal to 0. So that means they want me to solve this equation. So if you're a pre-calc student, pay attention to this. I'm going to isolate the cosine 3x. I'm going to switch the sides here, but it'll be cosine of 3x, right? I would add the 1 and divide by 2. So I'm trying to find when will cosine x, 3x, be equal to 1/2. Well, I'm still, I mean, this quantity here is an angle. I still want to consider where on the unit circle is cosine 1/2. That's going to be in the first and fourth quadrants. And that's going to be it's going to be at pi over 3 and 5 pi over 3. So I'm not going to go into why that is, but in other words, this angle is got to be equal to pi over 3 and 5 pi over 3. Those are the two places where cosine of an angle is 1/2. So to solve for x, I would be dividing by 3, and it would be pi over 9 and 5 pi over 9. And a lot of students would answer, it must be 2 solutions, but there's not. There's 6 solutions, because you have to know that if you end up dividing by 3, there are coterminal angles that are also solutions that when you divide them by 3, they'll be pulled into the interval 0 to 2 pi. This is what I mean. The next coterminal angle to pi over 3 is 7 pi over 3. The next coterminal angle to 5 pi over 3, when I add 2 pi to it, is 11 pi over 3, right? Taking 2 pi, adding it to 5 pi over 3 is 11 pi over 3. I'm going to go another one. I'm going to add another 2 pi to 7 pi over 3. It's 13 pi over 3. I'm going to add another 2 pi or 6 pi over 3 to this. 17 pi over 3. And remember, these are all equal to 3x. These are all angles whose cosine is 1/2. Then when I divide by 3, it turns all the denominators to 9s. All of these are 9s now, because that's what happens when you divide by 3. You're multiplying by 1/3. Aren't all of those angles between 0 and 2 pi? They are. Even this one is barely, but it is within 2 pi. So my answer here is 6, not 2. 6 solutions. All right, students. Well, it was a good showing tonight. We had quite a few students, more than we usually do. I appreciate you coming out tonight. Don't forget, next week, if you want me to work homework problems, send them in advance to askmrrich@gmail.com. I'll be happy to work them for you. Other than that, have a great night and a good week ahead. And maybe I'll see you next Sunday night. Take care, everybody. Bye.